It is said that the equation of line is given. Equation of line px plus qy plus r equal to 0. And the variables which are given to the arbitrary constants are, there is p, q, r, variable coefficients are connected by PA plus QB plus RC equal to 0. And we have to show that the line passes through a fixed point. Now what we can do here, first of all, our intention will be to remove this R. So to remove this R, we have to find the value of R from here. So here what we get, R equal to minus 1 by C AP plus QB. Now using the value of R in equation Px plus Qy plus R equal to 0. Qy minus 1 by C into AP equal to 0. Now here we take P common, X minus A by C. We take here Q common, Y minus B by C equal to 0. Now here X minus A by C plus Q by P into Y minus B by C equal to 0. Now what does this shows? That the required given line is passing the intersection of the two lines, this one and this one. So we can say here that the line Px plus Qy plus R equal to 0 passes through the intersection of the lines X equal to A by C and Y equal to B by C. Fixed point through which line passes is A by C, comma B by C. So equation of triangle is formed by the lines. Triangle is formed by the lines X equal to 0, Y equal to M1X plus C1, Y equal to M2X plus C2. We have to find the area of the triangle formed by this line. So what we'll do, at first we'll decode this in the Cartesian. So this is Y, this is X, this is X prime, this is origin, this is Y prime. Now X equal to 0 is this line. So this is the line X equal to 0. Now we have two other lines, Y equal to M1X plus C1, Y equal to M2X plus C2. So this one we take as Y equal to M1X plus C1, and we have another line which will be Y equal to M2X plus C2. Now this point we take as A, this point we take as B, this point we take as C. Now B and C can find out very easily. Why? Here B and C we can find very easily. How we can find? For B and C, for both the point x coordinate is 0. For both B and C, x coordinate is 0. So if x coordinate is 0, we can put here x coordinate equal to 0. If we put x equal to 0, y equal to C1 and y equal to C2. So we get the point B and C. 0, C2 and 0, C1. Now we have to find the point A. How can we find the point A? Just to solve the equation y equal to m1x plus c1 and y equal to x plus c2. So to obtain A, we solve equation y equal to m1x plus c1 and y equal to m2x plus c2. Now, how can we solve this? Point A we take as h comma. So h and k should satisfy this equation. So we can write k equal to m1h plus c1 and here k equal to m2h plus c2. Now we subtract. On subtracting we get this one as 0 h into m1 minus m2 plus c1 minus c2. Just we have subtracted. And therefore h equal to c1 minus c2 divided by m2 minus m1. Actually, we don't need anything else. K we don't need only to get the area. Why? To get the area, we need this horizontal distance which we have already got. This h. So we can say this is AD. So this is AD. And we have got this length also, we can find BC because we know B and C. So required area we can find directly. We know this side BC, so we can say here also that BC's line segment will be modulus of C2 minus C1. Modulus of C2 minus C1. So once we have got this, we can find the area. So here we can say that required area is, therefore, required area is half of AD into BC. So it is half of AD length already we have got. So AD in this case is modulus of, if we take the mod to get the area, we have to take the mod. It is C1 minus C2 by M2 minus M1 into mod of C2 minus C1. So this gives us half of within the mod C1 minus C2 whole square by M1 minus M2, which can be written as half of either C1 minus C2 or C2 minus C1 because it's a whole square, so no problem, by mod of M1 minus M2. And that is the required area. So a variable line passes the intersection of the two lines. So given equation of lines, are x by 3 plus y by 2 equal to 1 and x by 2 plus y by 3 equal to 1. So the required equation of line or equation of line passing through to the intersection of the lines x by 3 plus y by 2 minus 1 or equal to 1 and x by 2 plus y by 3 equal to 1 is given by x by 3 plus y by 2 minus 1 plus k into x by 2 plus y by 3 minus 1 equal to 0. So we have got this as the equation. Now if we simplify this one, x into 1 by 3 plus k by 2 plus y into half of k by 3 minus common k plus 1 equal to 0. We have to find here locus of the middle point of AB. AB is what? This line. This line at first we bring it the intercept form. That is x by k plus 1 by 2 plus 3k into 2 into 3 plus y by a plus 1 into 6 by 3 plus 2 equal to 1. So this is what we have got. Now if we represent this in the Cartesian, then this line will intersect x-axis and y-axis. Now this is the line. Now this point is A, this point is B. Now from here we can say what is OA? OA will be this length. What is OB? OB will be this length. And we have to find the midpoint because of the midpoint. So midpoint will take us H comma K. But we cannot take here K. We can take here because it is already K is taken. Here we can take the midpoint as alpha comma beta. So we take the midpoint as alpha comma beta. Now A is this one, OA is this length, OB is this length. Now we can find alpha comma beta. That was we write here. OA is equal to 6k plus 1 by 2 plus 3k, and OB equal to 6 into k plus 1 by 3 plus 2. And therefore we can find from here alpha. Alpha is what? A plus 0 by 2. So from there we can say that alpha would be 3 into k plus 1 by 2 plus 3k. And beta would be 3 into k plus 1 by 3 plus 2. Now, what is our intention? To find the algebraic relation between alpha and beta. How can we find? We can simplify this further. 3 alpha plus 3k alpha, 3k plus 3k. Now, from this, what we can say? That k into 3 alpha minus 3 equal to 3 minus 2 alpha. So k equal to 3 minus 2 alpha by 3 alpha minus 3, which we mark as equation 1. Similarly, we solve beta. So this will be 3 beta plus 2k beta equal to 3k plus 3. Now from this we can take k common. So 2 beta minus 3 equal to 3 minus 3 beta. So here k equal to 3 minus 3 beta by 2 beta minus 3. Okay. Now after that, we can equate these two values of k. So from 1 and 2, we can say that 3 minus 2 alpha by 3 alpha minus 3 equal to 3 minus 3 beta by 2 beta minus 3. So this gives us 6 beta minus 9 minus 4 alpha beta plus 6 alpha equal to 9 alpha minus 9 minus 9 alpha beta plus 9 beta. Now we can simplify this further. And what we get here? We have got here 9 alpha, here we have 6 alpha. So you take everything on the one side and then we can write that it will be 3 alpha, then it will be 3 beta minus 9 alpha beta, and if you take on the right hand side, this will be minus 5 alpha beta, and minus and cancel out. Now this gives us 3 by beta plus 3 by alpha equal to 5. Now if we replace alpha and beta by current coordinate x comma y, then we are done. So on replacing alpha comma beta by current coordinate x comma y, by current coordinate x comma y, that's a variable coordinate x comma y, we get the required locus. So 3 by y plus 3 by x equal to 5, which is the required locus we are getting. Given equation of the line AB is 3x plus 4y plus 9 equal to 0. Equation of the line AC is 4x minus 3y plus 16 equal to 0. Now we try to plot these lines in the Cartesian plane. So this is y, this is y prime, x prime, origin, and x. The first one, 3x plus 4y plus 9. So if we reduce the equation AB in the intercept form, we get here 3x plus 4y equal to minus 9. Now that gives us x by minus 3 plus y by minus 9 by 4 equal to 1. So this should be a line in the third quadrant. So we take here the line in the third. This is the line AB approximate. And we take this point as minus 3 comma 0, this point as 0 comma minus 9 by 4. And this is the line A. Now we try to locate the line AC. So for AC, also we try to take it in the intercept form, just for plotting it in the Cartesian plane. So it is 4x minus 3y equal to minus 16, and that gives us x by minus 4 plus y by 16 by 3 equal to 1. Now this should be a line approximately this. Here the line AC and AB are mutually perpendicular, because if you observe it carefully, we see that the coefficient got interchanged and the sign has also got changed. So this must be mutually perpendicular, or we can find the slopes and we can also check that. For example, for a slope of AB, we denote by m of AB. We get here that it is equal to minus 3 by 4. Similarly, we find a slope of AC and we get here 4 by 3. So definitely, if we find the product of these two slopes, that is equal to minus 1, so they are mutually perpendicular. So we got this mutually perpendicular. We got the lines are mutually perpendicular. Now this is the line AC. This is the line AC and this is the line A. So the point of intersection should be, so this is the point A. Now we have to find the equation of another line, that is BC. So you can say that this is the NB, this is a point in C. So just we join this approximately. So this is the point B, this is the point C. Here there is a point D, which is 5, 2, and is the point D divides the line BC in the ratio 4:5. So since it's 4:5, we can consider this as equal to some 4K, and this is some 5K, where K is the ratio proportion. So this is 4K length, approximately 4K, and this is 5K. Okay, so this is the 4K length, this is the 5K. And now, if we draw here a perpendicular on the line AC, then it will be something like this, and we draw a perpendicular over the line AB. Now this is the point L, this is the point M. Now to find the slope of the line BC. Now for getting the slope of the line BC, we need this angle. Now what are the angles we have? Here we can take this angle as some theta. And we have dropped a perpendicular here, so this is 90, this is also 90, this is also 90, so this should be 90. So this is 90, this is 90. So automatically this is 90. These are the perpendicular drop. So this is DL, this is a DM. DL is the here DL represents a perpendicular dropped from the point D, on AC, so that we can find out it is mode of AC equation is 4x minus 3y plus 16. So you can say it is 4 into 5 minus 3 into 2 plus 16 by under root of 4 square plus 3 square. Now this will be equal to 30 by 5, because it is 20 minus 6 plus 16. So this is 30 by 5, that is 6 unit. 6 unit. Now similarly, we can find here DM. DM is the perpendicular drop from now here what we'll get, it will be more or less, it is on AB, so it is 3 into 5 plus 4 into 2 plus 9 by under root of 3 square plus 4 square. Now this gives us 32 by 5. So this is what is that 32 by 5. Now if this is theta, this is 90 minus theta, and this will be theta. So we get here, this is theta, this is 90, this is 90. This is 90 minus theta, so this will be definitely theta. Now here we can say that this length is actually 4K sine theta. Similarly, this length is 5K cos theta. So we can write it here that DL by DM equal to DL by DM. Now this one was DL is 5K cos theta and dA means 4k sine theta equal to, this will be 30 by 30. So we have got here this cell in dm, which is 5k cos theta, is a dm, which is 4k sine theta. So that is what we have done. Now if we simplify this one, we get here the tan theta. Just if we take the reciprocal, we get tan theta. So tan theta is coming us here 4 by 3. So what you see, that we have to find the slope of the line BC. Now for that we take this angle as alpha, and we take this angle as some beta. Now tan beta we can find because you know the slope of AB. So we can say here that tan beta equal to minus 3 by 4. Now when we have this one beta and this one alpha, now this is also alpha, because vertically opposite angle. So you can say that this angle is also alpha. Now beta equal to alpha plus theta, but we have to find alpha. So what is alpha? Beta minus theta. Now tan theta into tan beta equal to minus 1. Now this implies tan beta equal to minus cos theta. And from this we can write tan of 90 plus theta. And from this we can say beta minus theta equal to 90. And therefore alpha equal to 90. And this implies line BC is vertical. And passing through D 5, 2. Therefore required equation of BC is x equals to 5.